Hello, students. Let's go over to biology of this pandemic. How are these three words related? You've probably heard them all used interchangeably. Hopefully, you got something along the lines of the coronavirus is a family of viruses. It's like a big branch, and from it come out these smaller branches that are the individual viruses. Here are the seven viruses, the seven coronaviruses that can infect humans. The first four give you the common cold, whereas the last three, MERS, SARS, and SARS-CoV-2, give you worse illnesses. SARS-CoV-2 is the virus that is currently causing the pandemic around the world. It causes the disease COVID-19. Okay, let's jump into this. What is a virus then? It's an interesting question. Viruses are parasites. Are they alive or are they dead? It's hard to tell, right? They have to have cells to live or to reproduce, and that's why they're called obligate intracellular parasites. So here's a picture of a virus infecting a bacterium. Here are those bacterium next to a regular colon cell. So you can see how small they are. They're ubiquitous. They're everywhere. There's more of them on Earth than there are stars in the universe. There's more viruses in Oman than there are grains of sand in Oman. This is a picture of a liter of seawater stained to show you all the viruses in it. How do they work? They dock with a cell and they come in. It'd be like if I had a key to your house and I walked in, used all of your ingredients in your kitchen to make a nice dinner, ate it, made a couple more copies of John Gibney, and then walked out and did it again in somebody else's house. That's what viruses do. They're able to dock here at a receptor, come in, and then use all the cell's machinery to reproduce. They don't use their own machinery, right? They use the cell's amino acids and ribosomes, etc., to make more copies of themselves. How did SARS-CoV-2 evolve? Well, you've probably heard it came from bats in China. And these horseshoe bats are interesting. They're the only mammals that can fly, and they harbor a lot of viruses. And so within the bats, viruses change over time. They mutate, right? Mutation is random, but natural selection is not. So eventually, the virus that is infecting humans was selected for, and it was able to spread in humans. And so Stanley Perlman from the University of Iowa and a doctor and PhD has a good quote. It is the lower respiratory severity of SARS and MERS coronaviruses and a transmissibility of cold coronaviruses. That's what makes SARS-CoV-2 so deadly. So how is it transmitted? Like I said, it is going to dock with some type of receptor. Here it's going to use the spike glycoprotein called S to attach to a receptor. It'd be like my key opens my door. It does not open Mr. Webster's, Miss Kelly's, or Miss Knudsen's door. It has to have the right receptor to dock with it. And so this one docks with what's called an ACE2 receptor. That ACE2 receptor is found all in our airways and in our lungs, and it's able to it wasn't designed for SARS-CoV-2, right? Like the ACE2 receptor deals with blood pressure and receives messages for that on different hormones. But the SARS-CoV-2 virus is able to dock with it. And so it comes into the cell and it then uses the cell's machinery to make more copies of itself. There's two websites I think that you should check out, nextstrain.org, which goes over to phylogenetics of it and looks at mutation rates, and it can kind of track the spread of it as people post open source information of the genome. The Johns Hopkins site, you've probably seen this, showing overall statistics of the coronavirus. And then I'd like to thank Mr. Yates for pushing me onto these gifts. What are some solutions, right? Well, right now we are doing physical distancing. We are flattening that curve. For people that have the virus, we're giving them fluids and oxygen. We're trying to make them comfortable. Antibiotics do not cure viruses, okay? The goals would be to develop a vaccine and to see if we could test currently available medications to stop the biosynthesis of viruses, develop drugs to block that viral mRNA, and some places are even trying to give people antibody transfusions. So once people that have survived the coronavirus, if they have the correct antibodies in their blood, maybe they can be shared. So you should research how the vaccines work. Right? An inactive form of the disease is introduced to the body. Your body then promotes antibodies to do that. That comes from the B cells congregated in your lymph nodes, and they go around and they serve as memory cells to quickly stop any recurrences of it. All right. Thank you.